Now, I talked in a previous video about how to draw Fisher projections. Let's talk about how to use Fisher projections in order to understand and assign chirality associated with their molecule. At least we're going to start working towards that direction. So, in our Fisher projection, we draw a straight line to designate the chain that we're associating with this compound. We have our CH3 group here, CH3 group here, and we have four atoms along the way. So, we have a bromine, hydrogen, 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 and OH and H. And I really haven't specified that they go like this in terms of this drawing, so if you're a little confused how I got that assignment, I haven't specified yet. We're not there yet. So, the Fisher projection is going to do two very useful things for us. One, it's going to help us much more easily tweeze out which version of the chiral compound we have. The second is it's going to make it a lot easier to see where the chiral centers are. So in the previous video I talked about how the hydroxide and the bromine are connected to chiral carbons. How do we see this in the Fisher projection? Well, the Fisher projection shows that if we look at this particular carbon, we have different groups left and right, and we have different groups tops and bottoms. So it's really quick, we can quickly see here now that this is a chiral carbon. Here, left, right, we have the same group. Up, down, we have different groups, so it doesn't matter. We have a redundancy in terms of our two groups. Same thing's true here. This is going to be chiral because left, right, we have different groups, and top, bottom, we have different groups. So this is going to help us quickly identify where our chiral centers are. Now, there are two ways to draw this structure. One where we have the OH group on the left side, one where we have on the right, and another two projections where we have the bromine on the right and the hydrogen on the left. So how are we going to translate this to our Newman projection? Well, this is where a modeling kit comes in really, really handy. So we have 6 carbons in our chain. So let's build a 6 model molecule. And we got a halogen in there somewhere. So what your Fisher projection is making it look like is if we always had the nearest carbons pointing away from us and whatever's attached to the carbon pointing towards us. So for this carbon, it's going to look like this. For the next carbon down, it's going to look like this. Carbon beneath that, like that. Carbon beneath that, it's going to look like this. So what we want to do is, if we can't see it visually, build the models. Now, typically, we draw, let's say we put the wedge here, and we put a dash here. We can basically project this by saying, what if we were looking right down the carbon-carbon bonds, what would we expect to see? So, again, we need to rotate this so this way all the carbons are facing away from us. And in the case where they're pointed up, your wedge here is going to be on the left, the dash is going to be in the back, and the point where on the sides where they're pointing down is going to be the reverse. The dash is going to be up front on the left side, the wedge is going to be on the right side. Now again, even with me, I need to build a modeling kit, so this is where it's going to come in really handy for building your Fisher projections. But build your models and project it, and the next video we'll talk about how to do the R and the S.